We're going to relate special triangles, okay, which we know, we have written out two of them here, into the four quadrants and how they can help us solve angles that are larger than 90 degrees. Okay, so I've drawn this line a little large, but here's kind of our Cartesian plane, right? We have our x and our y-axis. And what I want you to think about is almost like we have an arm of a circle. We'll give it one little end to it. We have an arm of a circle, and this circle is going to start right here on the x-axis and going to spin around in this type of fashion. Okay, so I'm going to leave it up just a bit. And if we were to do such a thing, if we start right here, well, obviously we're going to be at 0 degrees. There's going to be no change. As soon as we get up to our vertical y-axis, what degree would you say we're going to be at?
Degrees.
Exactly, we're going to be at 90 degrees. When we get back around to the other part of the x, how far would we? A little far. Think of adding 90 to 90.
Oh, 180.
Yeah, that's good. So we're going to be 180, which we would mean at the next one.
Oh, yeah, the next one is 270.
Yeah, exactly. So this one down here is going to be 270. And then finally, when we get all the way around a circular pattern, how far have we gone?
360.
Exactly, we've gone 360 degrees. Okay. Well, what we're going to be doing is we're going to use special triangles to essentially help us solve certain angles or distances of sides. Okay. So, for instance, if this arm was like this, we're always going to consider this arm the hypotenuse of any triangle we're going to build, because all of these are going to be right angle triangles. And what we're going to do is we're going to create right angle triangles from the hypotenuse. Okay. So, for instance, if they were to tell you that maybe this was 30 degrees. Well, I know this is 90 degrees because I know my special triangle. What that means is this point, I could literally solve this coordinate. This y coordinate, in other words, the height of this triangle would have to be 1. So that would be my y coordinate. And the base of this triangle would have to be root 3. Assuming we're working with a hypotenuse that is the value of 2 here. Okay. Now, what they're probably going to do a lot of the time is they're going to be working with a hypotenuse of a value of 1. Oh, sorry. I don't know. They can work with them with a value of 1. It completely depends. Okay. We could also be working with a hypotenuse that is root 2. So it's always important to keep that in mind, what hypotenuse they're trying to work with. But what we're going to do is we're just going to keep special triangles in mind because we're going to use this information to solve angles in other quadrants. So we know we could do it over here. But let's say they'd given us something over here, and they want you to solve for this obtuse angle here. Well, we have to recreate, again, a right angle triangle. So we use this information, and we recreate our right angle triangle again. Once we recreate our right angle triangle, again, let's say in this case we're dealing with, this is a value of 1, and this is a distance of 1 here. Even though it doesn't look symmetrical. Let's say that that's the case. That would have to mean this hypotenuse is root 2, and we would solve this angle using this information. If that's the case, this angle would be what? The small acute one.
45 degrees.
That's right, it would be 45 degrees, which would make our obtuse angle. How would we go about finding that?
Oh, 180 minus 45.
Exactly, we take that 180 and we subtract our 45, and what's that going to give us?
135.
Exactly, that would be 135 degrees. Now let's say we get into another quadrant here. This is the third quadrant. Okay. If I get into the third quadrant here, the best way we're going to be doing this is every time we make a right angle triangle, it's always in reference to our x-axis. Okay. So we wouldn't do this. Okay. We're always going to make the right angle touching the x-axis. So when we go about doing that, whatever this angle is, okay, we know that if we're trying to solve going from here all the way around, okay, if we're trying to solve from there all the way around, we'll have to add whatever this acute angle is to what value?
180.
That's right. We'll have to take 180 and add this angle. So I'm just going to call it angle A for acute angle. In this case here, what did we have to do with that angle?
We had to subtract it.
That's right. So over here in quadrant 2, we took 180 and subtracted the acute angle. In quadrant 1, we literally just solve for that acute angle. Okay? And then when we finally get into the fourth quadrant here, We'll still have to use the x-axis to build this.
Mhm.
So what would be the easiest way once we've discovered how much this angle is? What would be the easiest way to figure out this entire obtuse angle?
Subtract that from 360.
Exactly. So if we're in the fourth quadrant, we're taking 360 and subtracting our small acute angle within this. Okay? So really what we have to do, I drew third over there, that should be fourth. That's fourth quadrant. So really what we're doing here is we have to pay attention to, depending on where they want us to solve angles between. Because if they ask us to find a ratio between 0, okay, so if they say, oh, we want you to find the ratio of theta between 0 and 360, and then they tell you that you have maybe find the angle of sine theta when it's equal to 1 over root 2. Well, they've given us a very large range to solve for. Okay, I'm going to clean this up just a little so that we can kind of see what we're trying to solve here. Get rid of some of this stuff. Okay, so let's say they've given us that type of question. Well, what that means is we take this angle here, and what angle using special triangles gives us 1 over root 2?
45 degrees.
That's right. That would mean that this theta is equal to 45 degrees. Well, that's in the first quadrant, right? But if we're looking between 0 and 360, I also have to create the exact same idea. Okay, and what I'm going to do is I'm just going to copy, paste. Let's move this guy down here. We're going to have to create the exact same thing over here, right? Okay, which would then mean this small angle here is 45 degrees. But what would this angle actually be here? We solved it before.
90 degrees.
We're talking about the entire obtuse one, the one I drawn red. What will we have to do with that small acute angle? Exactly. We'll have to subtract it from 180, which will mean 135 degrees is also an option for theta. So 45, 135. Make this an infinite cloner. We'll also have to do an angle in the third quadrant. Okay. And an angle in the third quadrant, that's going to be, this small part's going to be 45 degrees. So let's use a different color here. Let's say green. This entire angle coming around in the third quadrant, what will we have to do with it?
Add it to 180.
So what do you think that'll give us?
215.
Is it 215? I think it's 220.
225.
Yeah. 225 is also an option for theta. Okay, so what I'm saying is, as you notice, we go through the quadrants, we're going to end up with 4 options for an answer here.
Okay.
And then in our last one, let's turn this around a little. In our last one here, we're going to have, again, we know this acute angle is going to be 45 degrees. And what are we going to have to do with that to find out another option?
Subtract from 360.
Yeah, so that's going to give us this purple one. And when we subtract that from 360, what are we going to get?
275.
I think it's going to be
280.
Let's try 360, subtract 45 degrees. 315. Yeah, okay. So 315. So in other words, what we discovered is theta has 4 answers to it. Theta can be 45 degrees, right? Theta can be 135 degrees, which was this guy here. Theta can be 225 degrees. And theta can be 315 degrees. There are 4 answers within that range. And we could continue to go in circles and circles and circles, but they'll usually probably just go between 0 and 360. Okay? So that's when they're talking about using these special triangles in the 4 quadrants.